Welcome back to Cosmos in a Pod. It's our Space and Astronomy series, and today we're going to be taking a deep dive into something called the Great Attractor.
Oh, yeah, the Great Attractor.
It's so fascinating how it influences the movement of galaxies across the universe,
Yeah.
Like all these galaxies out there in space doing their thing.
Yeah.
Turns out they're not just randomly floating around.
No,
They're actually part of this massive, like, cosmic dance.
I like that.
You know what I mean?
Yeah,
This flow driven by these powerful invisible forces.
that's right.
Almost like if you could imagine a giant invisible hand pulling entire clusters of galaxies across vast stretches of space.
Yeah.
That's kind of what the Great Attractor is doing, and that's what we're going to explore today.
Let's get into it.
So can you help me and our listeners understand this cosmic dance a little better?
Sure.
What is behind this pull on these galaxies?
Well, we got to start with the Great Attractor itself.
Okay.
So picture this, like a gravitational anomaly, a region of space. But this region of space has such immense gravity
Oh,
that it pulls everything towards it.
oh, okay.
And this thing is located about 150 to 250 million light years away from us.
Whoa, that's far.
Yeah, towards the Centaurus constellation.
So we're talking about something mind-bogglingly huge
Yeah,
and far away.
right.
How did astronomers even figure out it was there?
Well, it's kind of like a detective story, you know?
Oh, fun.
Back in the 70s and 80s, astronomers were studying the way galaxies move.
Yeah, makes sense.
And they noticed something interesting.
Mhm.
Our Milky Way, along with a whole bunch of other galaxies,
Uh-huh.
were moving towards a specific region.
Interesting.
But they were moving at a speed far greater
Oh,
than the visible matter around us could explain.
oh, so like way faster.
Way faster. Like
Yeah.
they were being pulled towards it.
So it's as if they stumbled upon a cosmic current
Yeah, you could say that.
that was just sweeping these galaxies along.
Exactly. That's a good way to put it. It was like watching a river flow uphill, you know?
Yeah.
Defying the laws of gravity as we knew them.
Yeah,
And that's when they realized there had to be something massive out there.
right.
Something invisible to us directly, but exerting this tremendous gravitational pull.
And they called that the Great Attractor.
They did.
Makes sense. This is where it gets really intriguing.
No.
If we can't see this Great Attractor,
Yeah.
how do we know anything about it?
Yeah, that's the big question, right?
Right.
It's a challenge for sure,
Yeah.
because this thing is hidden behind a dense part of our own Milky Way galaxy
Why?
called the Zone of Avoidance.
Really?
Yeah, and this zone is packed with dust and gas that obscures our view.
So it's like trying to peer through a thick fog.
Yeah, pretty much, like
Okay.
a cosmic fog, right?
Right.
So how do they do it?
So how do astronomers penetrate this cosmic fog?
So they've had to get creative.
Yeah.
They use special tools like infrared and X-ray telescopes,
Hmm.
and these can see beyond the visible light spectrum.
Wow.
So they can kind of pierce through the dust and gas and allow us to catch glimpses of the galaxies and clusters being pulled towards the Great Attractor.
Oh, that's so cool.
Uh,
So it sounds like we're using like night vision goggles
Yeah, something like that.
to see through the darkness.
Right.
Yeah. So what have we learned from these glimpses?
Okay, so
What is the Great Attractor actually made of?
Well, that's a question that's puzzled astronomers for decades. We know it exerts a massive gravitational pull,
Right.
but the exact composition,
Yeah.
we're still debating it.
Is it like one gigantic object?
It's not a single object, no.
Okay.
It's more like a region of space
Okay.
filled with a lot of stuff.
Okay, like what?
Likely a combination of, regular matter,
Yeah.
like galaxies and gas clouds,
Uh,
but also something far more mysterious,
what's that?
dark matter.
Ooh, dark matter. Okay, you've definitely piqued my curiosity.
Yeah.
Can you explain what dark matter is
Yeah.
and why it's important in this context?
Okay, so dark matter is this fascinating enigma.
Okay.
It doesn't interact with light, so we can't see it directly.
Why?
It's like a phantom presence in the universe.
So how do we even know it's there?
We can kind of infer its existence, though, right?
Yeah.
Through its gravitational effects
Okay.
on things that we can see, like the way galaxies move and cluster together.
Mm-hmm.
It's as if dark matter acts like, like an invisible scaffolding,
Oh, okay.
holding the universe together.
And this invisible scaffolding plays a role in the Great Attractor.
Oh, absolutely. The Great Attractor, with its immense gravity, is like the prime suspect for holding huge amounts of dark matter.
Oh, wow.
So it suggests that dark matter is concentrated in that region, contributing to this powerful attraction.
This is mind-blowing.
Hmm.
So, given all this gravitational pull, is everything just going to fall into this great attractor eventually?
That's a good question.
Is that the ultimate fate of our galaxy and others caught in its web?
That question leads us to another force at play. Dark energy.
Oh, dark energy. There we go.
The universe is expanding, right?
Uh-huh.
And that expansion, it's actually accelerating because
Yeah.
of this mysterious dark energy.
Okay.
It's like a cosmic anti-gravity, pushing everything apart.
So we've got this cosmic tug-of-war going on.
Exactly.
Gravity's pulling things in, dark energy's pushing them apart.
Yeah, the outcome.
Yeah.
It's uncertain.
Oh.
We don't know if the Great Attractor will win and pull everything in, or if the universe will just keep expanding, pushing things apart.
Oh, my God.
It's a mystery
Yeah.
with enormous implications for the future of the cosmos.
Right. This is also fascinating.
It is.
It seems like the Great Attractor is just one piece of a much larger cosmic puzzle.
You got it.
Are there other attractors out there in the universe?
Yeah.
Other regions with this kind of gravitational influence?
The Great Attractor is part of a larger cosmic flow, like a grand dance of galaxies driven by gravity.
Yeah.
And there are other massive structures out there, like superclusters of galaxies, that exert significant gravitational influence on their surroundings.
So it's like a whole network of these cosmic influencers.
Yeah, think of it like that.
All shaping the universe on a grand scale.
It's all interconnected, you see. This intricate web of gravitational forces constantly pulling and pushing, shaping the cosmos as we know it. And the Great Attractor, just one piece of this grand cosmic ballet.
Well, this has been an incredible journey so far.
Just the beginning.
Yeah. It's amazing to think about these unseen forces shaping the cosmos and influencing the destiny of galaxies, including our own.
Yeah, it is pretty amazing, isn't it? It's a testament to the power of gravity and the interconnectedness of everything in the universe.
This is just the beginning of our deep dive into the Great Attractor. We'll be back after a short break to delve even deeper into this cosmic enigma. Stay tuned.
We're back and still on this journey to the Great Attractor.
I know, it's like we went to the break, but my mind never left the Great Attractor.
Yeah.
You mentioned before the break that it's part of this larger cosmic flow.
Right.
Can you elaborate on what that means?
Sure.
And like, how does it shape the universe on such a grand scale?
Okay, so imagine the universe like a vast cosmic ocean
Oh, I like that.
with currents and eddies swirling around.
Okay.
That's a simplified way to picture cosmic flow.
Okay.
It's the overall movement of galaxies, galaxy clusters, due to the gravitational influence of these massive structures like the Great Attractor.
Oh, okay. So
Yeah.
these attractors are like massive cosmic whirlpools,
Yeah.
just drawing in everything around them.
Yeah, that's a good analogy.
Okay.
But it's important to remember this pull isn't instantaneous or even uniform.
Right.
The universe is also expanding.
Right.
And that expansion is accelerating because of dark energy, remember?
Right. That cosmic tug of war between gravity and dark energy.
Yes.
So how does the Great Attractor factor into this cosmic dance?
Wow.
Is it powerful enough to overcome the expansion of the universe?
That's a question that's still being debated, to be honest.
Okay.
It's likely that the fate of galaxies caught in the Great Attractor's pull
Right.
is a complex interplay of these forces.
Yeah.
Some models suggest they might actually merge
Really?
into a giant super galaxy,
Wow.
while others point to the universe's expansion just tearing them apart.
Oh, my goodness.
Yeah.
So it's not a guaranteed everything collapses into the Great Attractor scenario.
Not necessarily, no.
Okay.
There are many factors at play, you know?
Right.
And the final outcome is still very uncertain. It's a reminder that the universe is constantly evolving, and these cosmic forces are in this, like, delicate balance.
Yeah. This makes me wonder about our own Milky Way galaxy.
Yeah.
We know it's moving towards the Great Attractor.
Right.
Is that something we should be worried about?
Not really. I mean, the time scales involved in these cosmic movements are incredibly vast. We're talking billions of years.
Okay.
Plus, as we mentioned, the universe's expansion is also a powerful force,
Right.
and it's unclear which force will ultimately dominate.
Yeah. Yeah. Okay, that's reassuring. But it still begs the question, what lies at the heart of this Great Attractor? Is it just a massive concentration of galaxies and dark matter?
Wow.
Or is there something even more exotic at play?
That's one of the biggest mysteries surrounding the Great Attractor, right?
Yeah.
It's difficult to observe directly because, remember, it's obscured by the zone of avoidance.
Oh, right.
But scientists do have some intriguing theories.
Like what? Spill the cosmic tea.
Well, some researchers think there might be a supermassive black hole
Oh, wow.
lurking at the center of the Great Attractor.
What?
A black hole so massive that its gravitational pull anchors the entire region.
A supermassive black hole. That's wild.
It is a pretty wild idea.
Yeah.
But it's not outside the realm of possibility, right? I mean, supermassive black holes exist at the centers of many galaxies, including our own.
True. So this supermassive black hole, if it exists, would be like the conductor of this cosmic orchestra,
Yeah.
dictating the movements of all the galaxies in the Great Attractor region.
It's a compelling thought.
Yeah.
But it's important to remember this is still a hypothesis.
Yeah.
And more research is needed to confirm or refute it.
Okay. So we've got this massive region of space, immense gravity, possibly anchored by a supermassive black hole,
Possible.
pulling in galaxies from vast distances.
Yeah.
What tools and techniques are astronomers using to unravel these mysteries?
Okay, so astronomers are using a whole arsenal of cutting-edge tools
Oh, cool.
to study the Great Attractor.
Yeah.
One approach is using radio telescopes
Okay.
to map the distribution of hydrogen gas in the universe.
Why hydrogen gas?
Well, hydrogen is the most abundant element in the cosmos,
Oh, okay.
and it emits radio waves that can penetrate through the dust and gas.
Oh.
That obscures our view of the Great Attractor.
So it's like using a special kind of X-ray vision
Yeah, exactly.
to see through the cosmic fog.
By mapping the hydrogen gas, astronomers can trace the large-scale structure of the universe,
Wow.
including the filaments and clusters of galaxies that make up the Great Attractor.
So we're talking about creating a 3D map
Pretty much.
of the cosmic web,
Yeah,
showing how all these structures are connected.
exactly. And these maps,
Yeah.
they're giving us an unprecedented view of the cosmic landscape and helping us understand how the Great Attractor fits into the grand scheme of things.
That's amazing. It's like piecing together a giant cosmic puzzle.
It is, yeah.
What other techniques are being used to study the Great Attractor?
Another powerful tool is gravitational lensing.
Okay, remind me what's gravitational lensing.
Okay, so it's a phenomenon predicted by Einstein's theory of general relativity.
Okay, got it.
Essentially, massive objects like galaxies and clusters can bend the path of light, passing by them.
Really?
Like using a giant cosmic magnifying glass.
Whoa, okay. So how does that help us study the Great Attractor?
By studying the way light is distorted by the Great Attractor,
Yeah.
astronomers can infer the distribution of mass within it, including the invisible dark matter.
It's like weighing the Great Attractor by measuring how much it bends the light around it.
That's a great way to put it. And these studies,
Yeah.
they're providing valuable insights into the composition and structure of the Great Attractor.
Even though we can't observe it directly.
Even though we can't observe it directly.
That's incredible. It's amazing how astronomers are finding ways to study these incredibly distant and invisible objects. What are some of the key questions that researchers are hoping to answer about the Great Attractor in the coming years?
Oh, there are many unanswered questions, but some of the most pressing, I think, are like, what exactly is the nature of the object or objects at the center of the Great Attractor? How does its influence extend across such vast distances? And perhaps most importantly, how does the interplay between its pull and the universe's expansion shape the ultimate fate of galaxies caught in its web?
Those are some big questions. It sounds like we're on the verge of some major breakthroughs in our understanding of the Great Attractor and the universe as a whole.
Yeah, I think so too.
I'm eager to see what new discoveries and insights emerge in the coming years.
Me too. The Great Attractor is a powerful reminder that the universe is full of wonders and mysteries,
Yeah.
and our quest to understand them is an ongoing journey.
Well, this has been an incredible deep dive into the Great Attractor.
Yeah.
I'm still reeling from all the mind-blowing information we've covered.
It's a lot to take in.
But before we wrap things up, I have one last question for you.
Okay, shoot.
If you could leave our listeners with one takeaway message about the Great Attractor, what would it be?
If I had to pick one takeaway message, it would be this. The universe is dynamic. It's interconnected. The Great Attractor is just one example, one of these powerful forces that shape the cosmos on this grand scale. And these forces, they're always at work, right? pulling, pushing,
Yeah.
shaping the destiny of galaxies, driving the evolution of the universe itself.
Yeah, it really makes you feel small, doesn't it? Like we're just a tiny part of something so much bigger than ourselves.
Absolutely. And there's so much we still don't know.
That's true. That's what makes it exciting, though, right?
Exactly. Every new discovery, it opens up new paths to explore, new ways of understanding our place in the cosmos.
So true.
Yeah.
Speaking of new discoveries, what kind of research do you think will help us learn more about the Great Attractor in the future?
Well, one area I'm really excited about,
Yeah.
it's the development of even more powerful telescopes and observation techniques.
Oh, cool.
For example, you've got the Square Kilometer Array,
The what?
SKA.
SKA, okay.
It's going to be the world's largest radio telescope,
Oh, wow.
capable of seeing deeper into the universe than ever before.
That's incredible.
Yeah.
How will that help us study the Great Attractor specifically?
Well, the SKA's sensitivity and resolution,
Yeah.
it'll allow us to create much more detailed maps. You know, those maps of hydrogen gas distribution.
Right.
We'll be able to see the cosmic web structure in amazing detail. And that's not all. It will also let us study galaxy movements with incredible precision, helping us understand those gravitational forces at play in the Great Attractor region.
So it's like we had this blurry picture before, and now we're getting a high-res version.
Yeah, exactly. And with all those new details,
Yeah.
we'll have a much deeper understanding of how the universe works, what makes it tick.
That's so cool. Besides the SKA, what else? Are there other things helping us study the Great Attractor?
Oh, yeah, definitely. Advances in computer simulations and theoretical modeling.
Okay.
They're really crucial, too.
How so?
Well, think about it. These simulations let us test different theories about how those large-scale structures in the universe form and evolve.
Oh, I see.
We can play around with different parameters, like how much dark matter is there? What about dark energy? And then we can see how the simulation plays out over time. And then, the exciting part, comparing these simulations to actual observations from telescopes.
Oh.
That's how we fine-tune our understanding of the Great Attractor, how it came to be, and what might happen to it in the future.
So it's like a combination of actually observing the universe and also creating these models to test out our theories.
Exactly. It's a team effort, observation and theoretical modeling.
Mm.
And as we gather more data, build more sophisticated models,
Yeah.
I'm really confident we'll crack the code of the Great Attractor.
That's awesome. Well, this has been an amazing journey of discovery. We've explored these unseen forces shaping the cosmos, delved into the mysteries of dark matter and dark energy, and we've learned about the incredible tools and techniques that are helping us unlock the secrets of the Great Attractor.
It's been a fantastic journey. I'm glad we could share it with everyone.
And for our listeners, remember to keep looking up and exploring. The universe is full of wonders, and the Great Attractor is just one example of what's out there waiting to be discovered.
Couldn't agree more. It's all about curiosity, that drive to keep asking questions, keep searching for answers.
And to all our listeners, if you want to learn more about the Great Attractor or any of those other cosmic mysteries, make sure you're following us on social media and subscribe to our podcast and YouTube channel. We're always posting new stuff, the latest discoveries, insights, all that good stuff.
Absolutely. Stay tuned. We've got more exciting deep dives into the cosmos coming your way.
So until next time, keep exploring the universe.